All right, I think we can get started. Quick show of hands. How many of you are web developers over here? Write web applications? OK, it's a fair few. How many of you still continue to write desktop applications? All right, maybe that's it's a 20-80 split, I guess. Anyway, one of the things about both kinds of applications is that they use completely different technologies when you're writing them. If you look at web application, HTML, JavaScript, CSS. One nice thing about writing web applications is you can actually write it once, and no matter what operating system that you're running it, whether it is on a when you're running it on Linux, Mac, or Windows, you can still run it without any problems. And pretty much more or less, irrespective of what kind of browser you use, whether it's a Chrome or Safari or Edge or IE, it more or less works, right? Desktop applications, on the other hand, completely different technology when you're writing it. How many of you still writing web using WinForms? Well, a few hands, right?
Yeah. Don't be scared, guys.
Yeah.
We are not going to judge you, right?
What about WPF? Yeah? Yeah, more like it.
Who actually did Silverlight in one moment of your life?
Yeah, Silverlight. I almost became a Silverlight MVP. Irrespective of what you do, I mean, like if you look at a web application, even if you're using C# or ASP.NET or even VB.NET and even Java on the server, effectively it splits out HTML, right? On the other hand, when you're writing a desktop application, completely different technology. And we even have legacy applications that are in our company that use Delphi. Anybody done Delphi? Yeah?
Yeah.
Oh,
it's
wow.
a 20 years old application.
Yeah.
It was written with the first version, the first beta version of Delphi for Windows 3.1.
Yeah. The biggest problem with all the desktop applications is that, well, they run on Windows fairly well. Even the Delphi application runs, even now it runs quite well. But when you want to start moving it across to a Mac or Linux, when you want to make it cross-platform, you have a big problem. And the web applications, right? I mean, like you can run it on a browser, and it's pretty good. But then the problem with the browser is it runs in a sandbox environment. And you want to say, well, you know what? I want to go pick some files from the file system and display it on the browser. You can't do it. It's off limits, right? If you want to connect to a database, you can't do it. I mean, you can do it through some code running on the server and things like that, but you just can't do it, right? It's all sandbox environment. That's the way it's meant to be. Now, but wouldn't it be cool? Like, wouldn't it be awesome, right, if you could actually use the same web technology, HTML, JavaScript? You guys were in Scott Hanselman's keynote yesterday, right? You know how he was actually talking about JavaScript being the assembly language of the web and things like that, and how how everybody should be using it. Wouldn't it be cool if you could use all the same technologies that we are really familiar with, HTML, JavaScript, CSS, and write applications, desktop applications? Use leverage the power of the desktop, but write it with HTML. That's what this talk is all about. It's all about a technology called Electron. My name is Mahesh Krishnan. I work as CTO at Telstra Health. Got a grand title of CTO, but I'm a developer at heart. And my co-presenter is Cristian Prieto. He's the technical architect. Oh, sorry, he's the technical lead.
No, Mahesh, no.
He's the technical lead. Well, one thing about Cristian is when I offered him the job, I said, oh, you come and join me and join as an architect. And he said, you know what? I just want one change. I said, what is it? Do you want more salary? He said, no. More perks? No. Can you please change the title from architect to something else? So what is it, Cristian? Are there any architects, by the way?
It's all right. Any architects around here?
Yeah. Sorry,
okay.
Don't feel shy, all right?
Yeah. Without any offense or things like that, but I work for a big company, a big corporation. And in that big corporation, architects had the title of throwing boxes and tell somebody else to do. And I love code. So I said, like, you know what? I want to write code. This is what I do. So can you just change the title without any offense, right? I don't want to offend architects here, but that's the difference. I write code. Yeah. Architects where I work don't.
I'll let you know on a tip, all right? If you really want to annoy Cristian, don't call him an architect. call them an enterprise architect.
Oh, yeah, that's the worst.
Anyway, coming back to our topic. So what is Electron? So by the way, do you get this thing? It's an atom, and it's got electron and everything else. I thought it was pretty cool, right? And Cristian thinks it's pretty lame.
I don't like it.
And of course, I'm his boss, so I get to choose this.
Just I have to say yes, it's pretty.
So what is Electron? You go look at the tech. You go look at the website on, and you got this definition. It's a framework for building cross-platform, blah 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 blah. But what does it really mean, right? 3 things. One is you can use Electron to write desktop applications using web technologies. The stuff that I actually said earlier: HTML, JavaScript, CSS, and you can use any JavaScript framework, whether it is Angular. How many people use Angular over here? Yeah? 1 or 2, right? 1, 2, OK. Whatever you want, right? Angular 1, Angular 2. You can use React. You can even use, the library that Scott Hanselman was showing yesterday. Was it FastScroll.js?
FastScroll.js, best library ever.
Yeah. You can use it, put it in a demo, and get your boss to demo it in a really important meeting. That'll go down well. Anyway, it really doesn't matter, right? You can use any JavaScript library that you want to use. And the nice thing about, and the reason that everything actually works in a desktop application is that they run everything in Chromium. So Chromium, for all those that don't know, it's effectively the open source version of the Chrome browser that Google has provided. Now, it comes with the V8 JavaScript engine, and it can run all the JavaScript and Node.js as well in it. Okay? One nice thing about actually running it on a Chrome browser or Chromium browser is that unlike a web application where you got to test it on different browser types like Firefox and Edge and IE and things like that, you don't have to worry about anything. You don't have to worry about whether Chrome is installed on the on the user's machine or anything. It's all packaged together, and they can actually use it.
Yeah, and that is important. We actually have to deal with an application that, to make sure that it will look correctly, as part of the installer, we have to install Chrome. So just imagine that's how things can become critical.
Yeah. So this is a really nice thing. But when you're running in a browser, it's all sandbox, right? If you want to, like I said earlier, if you wanted to use any of the access the file system, any system level functionality and things like that, you just cannot use it. But with Electron, you can actually do it. The second thing is that this is an open source project from GitHub. Now, have any of you looked at Atom editor, right? So Atom is a text editor from GitHub, and they started on this project about 3 years ago. And I think they started looking at other things like Node WebKit and a few other options that they looked at. And they found none of that really suitable for what they wanted to do, which is effectively build a text editor in HTML and JavaScript. So what do? They roll out their own, right? And so in 2014, they open sourced it. It was called Atom Shell back then. And then in 2015, it effectively became Electron.
Yeah, if you are a little more interested about this, Brendan Foster from GitHub is giving a talk about how they made Electron, and it's tomorrow at 11:40.
Yeah, and he's going to be talking about the internals of how everything works and everything else as well. So highly recommend going to the talk. But it's the reason I actually mention this is that it's not like a small side project that's being done by a couple of people. Yeah. I mean, it's got a lot of backing, particularly from GitHub, and there are a lot of big companies that are using it, including people like Microsoft. The third thing I want to do is, like, we talk about cross-platform. It works on Windows, Mac, and Linux. And you can package your application, and then you can you can run it on these 3 platforms. And you get the native look and feel on the platform that you're running it, and that's the key thing. It's not like you run it on a web browser and everything just works on, it doesn't look like a native application, right? It does, because it uses all the native components in it. I know some people are probably thinking at this time, like, hey, how is this different? You actually said that it's actually like a shell that's running like a browser window on it, a browser shell, and it's running HTML on it. How is it different to, let's say, running a WinForms application.
Or a WPF application.
Or yeah, that one as well.
Yeah.
Or actually having a browser control on it.
Yeah.
Right? I mean, the same thing works, right? You can pass a URL to it, and this works. I mean, you know, I've got a desktop application, and I'm writing using HTML on it. So why is it, Cristian?
OK, that is actually a good question. And I have a story related to that with work. When I just got into the job, I have to go and see all the other projects. And one of those projects I remember was a WinForm application. And when I go there, they just display a map and displays a lot of data in a table and things like that. And I remember asking to the developer, hey, these controls look really nice. Which control set are you using? Because it's WinForm. It's like, oh, no, we couldn't find anything that adjusted what we wanted. So what we do is that we generate HTML on the fly and then display that in a web browser, right, and a web browser control. So again, like just to complement that, it happens, and people does that.
Yeah.
The difference is you can just do cross-platform, let's use Xamarin Forms, and put a web control over there. There are like two big differences with that. The first one is that in all those applications, you are tied to the web control of the operating system. So in the case of Windows, you will use Internet Explorer Renderer, right? Not even Edge, Internet Explorer Renderer for Windows. And if you are using something like, for example, Mac, you will use UI WebView. So that's the first difference. And the second big difference is that you are basically having an application inside another application. Because it's inside a web browser, it's in a shell, it's sandbox. You cannot escape from that web page.
Yeah.
So even you can lie to yourself and say things like, oh, I can open a file because I will use the file browser stuff. But no, that's not the thing. You cannot get out from that.
Yeah.
So you cannot even communicate from that web view to the application that is your container.
Yeah. Effectively, you think about it as two separate applications. One is the application that is hosting the shell, and that's independent, and you do stuff with it. And then you have the browser control, and that is independent, and they don't talk to each other. And that's not what we want to have.
Yeah.
We want to have a seamless application. It's all written in HTML, and it can also go out and access things from the file menu, or you do things from the file menu, and things happen on the web browser.
Yeah.
So how does the structure of an Electron application look like? So let's go in and quickly look at a very simple Hello World application on Electron. It consists of three components, three files, if I can call it that, right? If you are familiar with Node, you probably recognize package.json. So what the package.json file contains effectively nothing more than the name of the application and the entry point for the JavaScript file, where the application needs to start. And if I go look at the JavaScript file itself, it's also pretty simple. I mean, it's got two main things in it that I want to point at. One is that when the application is ready, you're basically telling it, when that event happens, go ahead and create a window. What the create window function does is it actually goes ahead and does this. It creates a new browser window. You set a width and the height and everything.
Yeah, we will talk a little more about this in the next slide. So.
And then all you do is you load a URL. And that URL is effectively the index.html file that I've got as a third file. In this case, the index.html is an extremely simple one, right? It's a hello world HTML. It does really nothing much. And that's it, right? So once you create these three files, that's enough to get you started with an Electron application. Now, if you're writing a complex application, obviously you'll have a lot more files. You'll arrange it in a nice, much better folder structure. You will have your JavaScript libraries. You'll have your CSS files. And you have a lot more HTML files and things like that. But this is a very trivial example with just three files. This can actually get you started. Now, there are two processes that Electron application will run. One is the main process and the render process. Do you want to talk a little bit more about that, Cristian?
Yeah, sure. As I said, it's not just a web browser embedded in a main application. That is not. The secret here is that you cannot, from web technologies, access things regarding to the desktop and things like that. That's a fact. So what they did, but you can do that from Node.js, for example. So what you have is what they call the main process. In the main process is the thing that access with everything else, the menus, the file system, everything else. It's like Node.js. In fact, it's based in the Node.js source code. It's an V8 engine, but it's not Node.js. As I said, you have like access to the IPC, Node.js NPM modules. So all the modules from NPM, you can use them. Right? So all those thousands of modules from Node.js, you can use in your Electron applications. Dialogues and menus are from there. And then what happens is that every time that you want to display something in a window, you create another process that is called the render process. And that render process contains your HTML file. Right? And now this is the stuff, how they communicate. They didn't create a new protocol or anything like that. Operating systems, since the beginning, they just have this deal to communicate between two processes. So they use IPC. An IPC module is, or package or support are in both sides. So every time that, for example, you want to know that somebody clicks in the file open or file something in an action, if that has to affect, in any case, the render process, you just like do an IPC message using Node.js, IPC mechanism, and the other receives that, and you can change the UI. That is very useful as well, because you can have as many render processes as you have. It's very common in a Windows desktop application, Mac desktop, especially Mac desktop application, that you have the document metaphor, and you have many documents open at the same time in different windows. So that's the big difference. The main process is the equivalent to the things that is running and you cannot see, and can spawn as many browser processes as you want.
You can look at it in a slightly different way as well. You can think of the Chrome that actually runs it as the main process.
Yeah, so you see here that you have the title, the file, the menu, things like that are interacting directly with that. For example, notifications and things like that as part of the main process. And then you have the render with the controls and the thing that you display that's in the render of window process, the browser window.
Yeah. So what do you do to run this application itself? Pretty simple. I mean, of course, you need all the Electron bits to run it. So if you've got Node already installed, you basically go and say npm install, and you pass Electron pre-built into it. And that's it, right? That installs all that component. Obviously, we want to do it here, with the total bandwidth and everything else.
Yeah, exactly. It's like using Angular 2. You will download the whole internet. Right. One important thing here, and I will go skip, is that you can build your own version of Electron. You can download the source code and build it. You will just need the GIP, that is the Node.js binary system for compilation. But I would recommend the Electron pre-built. It will just download the binaries for the operating system that you are running in that moment. So if you run this in Windows, it will run the binaries for Windows, for Mac, the same thing, and so on.
Once you do that, Electron followed by the name of the folder where you've got all your files, and that's it. Very simple, and you'll have it up and running.
Yeah, Electron is just going to run your package.json file that is in that folder. We'll find the main entry. I will try to run that as the main entry. See that the main JS file of the main entry is the equivalent to your main code in C# or something like that.
All right, so it's demo time. And so what I want to do is we want to show you a bunch of applications, starting with we'll show a bunch of applications that that are available that have been already written in Electron. But quickly, I'll show you that Hello World app, and it's not much of an application, but what I want to show you is, I mean, of course, there's nothing much to it. It looks like any other desktop application. It's got a file menu and everything else. It's not much. However, if I hit Control-Shift-I, because it's running on the Chromium browser, I actually get all the dev tools that are there in the Chrome browser, right? You can disable this if you want, but that actually shows up. And the resolution is pretty crappy, but But if I actually look at, I can do inspect objects and a whole bunch of things that you would normally do. If you have JavaScript code, you can actually look at it. You can see what components have been downloaded and all those things that you would normally do when you're debugging an application in Chrome itself. So you get all those features built in. Just to give you a quick summary of applications that are available that have been written on Electron. Let's see, how many of you have actually used Visual Studio Code? Anyone? Did you guys know that it was written in Electron? Yeah? What about Slack? Slack's written on an Electron as well. So these are some of the apps that are written. People actually use it all the time, but they don't realize that it's actually being written in Electron. Now, with Slack, for example, Jesus. I thought I disabled all of those things, all right?
I have many birthdays today, man.
Yeah. Apparently, Struyhunt's birthday today as well. Did you guys know? So, notice this is Slack, right? So notice that it had integration on the system tray. And let's not run Slack now at this point.
It's just playing the Wi-Fi.
That's the internet. It's really awesome. So anyway, so notice that it actually had this integration of the system tray. All this is actually possible because of the close integration that it has with the native operating system itself. So on a Mac, this will look different. On Windows, obviously, it pops up over here and so on. Now, it's probably a good idea to jump in and do a quick demo of.
Yeah, another few applications that I love as well that has been written with Electron. Let's try this to see if it works. Who knows? Can you connect this?
It's on that side.
I'm sorry, man. I'm totally new to Mac. That's too new. OK. The first thing is that the guys from Electron itself, they have a long list of applications that has been written with Electron. Some of them you actually get surprised that they were written with Electron. As you can see, one of them is Visual Studio Code. This is Visual Studio Code with a C++ project, or a C project. I'm not a C++ guy. I prefer plain C. Notice the menu integration. And one of the favorite things that I see in Visual Studio Code, and you can just open directories, inspect the content of directories, inspect the type of files, things that you cannot do in a web application. Because all of those things, what happens is they are happening in the main process, and they are just telling to the render process, this is the list, right? So that is an important tip. If you try to do things that's complex as this, you have to create your own protocol, or the lightweight protocol between those two things to talk and communicate. Another thing that we can see here that I actually like it a lot is that thanks to that you are running something locally, you have the power to leverage extensions. You can create extension points in your JavaScript application, so you allow all the users to extend your application using plugins. That was one of the first things that we started looking when we started designing the new applications, or the new breed of applications that we have to work with. We work in the medical industry, and it's very common there that you have you cannot think ahead all the things that hospitals or people are going to do with your software. So it would be easier for them to say, like, you know what, we have extension points, and you can just create your own UI for that specific thing and things like that. And the only thing that you have to do is just create a package and things like that, and it's JavaScript, and it will work. And that is one of the things that I love from running Electron applications. You can just see in the examples, and most of them support plugins. And it's pretty simple. Another application that I like a lot is the one who started everything. Obviously, Atom. Atom is awesome. I like it. It's basically kind of an IDE. It's not just an editor anymore. One of the things that you can see here as well is the support for themes. How does this work? And it's very common, the same as plugins. I want my application to look different. Think about the support for your local desktop application to support branding. That you want to bring branding to different customers depending on the store. In the case, again, of medical industry, depending on the hospital, we want the application to look very different. So the reason because this is easy to do in Electron is that the branding or the theme support is just CSS. It's just plain web technology. You can just make it look as different as you want. There are just HTML elements that will make things change. So that is the secret in Atom with the themes. And you just can make it look completely different. I hate in Atom the light theme, so let's return to the dark. Another application that we have here is Wagon. Wagon is a data science application. It's basically a SQL browser. One of the things that it does is that you can connect to database. Note, an NP has a huge variety of support for databases in the NPM catalog. So the way that it works is that actually Wagon embeds Haskell with the application to just do all the data science processing and things like that with algorithm or machine learning. So another good thing, if you already have IP written in other things and it's cross-platform, you can embed that in the package for your application and ship it. So again, the communication between processing and operating system happen through IPC. So just change that to make it IPC aware. And one of my favorites that sadly I haven't finished is Nylas. That for some reason, well, let's go to the beginning. At least we have here. I just didn't try to do the setup today, and the wireless didn't let me. And it's a mail client. But if you can see the screenshot here, the resolution is not very well, it doesn't look like a web application. It has the Chromium of the Chrome of a Mac, and it supports plugins as well, themes, things like that. So you can't create native desktop applications, use just pure HTML. And well, the other would be your application, probably. You can just submit as well to the Electron website. And there's plenty of applications done with Electron. They do things that you cannot imagine. A good example of that is how many times somebody asks you, can we support video conferencing in our application? You can't in a web application. So you can just now use as well video conferencing using the native desktop. Let's say that you want to support speech with now the APIs that both Mac and Windows have for speech. You can do that as well. In fact, if there is something native that you want to support, you can write as well your own native modules to Electron to do that and ship it with your application.
All right. So let's look at, we've done the demo. So let's look at how to get started. I mean, for a lot of people, you already have an existing application that you're thinking about, hey, how do I actually move this across to Electron, right? So, so how do we do it? Well, the first step is, of course, you know the URL that you actually have on the JavaScript file where you do the create browser? You can basically chuck in the URL. Okay? It's like a first step. But there are issues over here, right, Cristian? Yeah. The biggest issue, of course, is security.
Yeah. So let's talk about the first one by one.
Yeah. The first one is, of course, let's go in. So the first one, of course, is to serve the content, server content from the server. So all your HTML, all your JavaScript and CSS and everything is actually in the server. And all you're doing is passing the URL of your index.html.
Yeah, right? Actually, this could be useful, but very dangerous. What happened is that if you remember the first slide, one of the first slides that Mahesh showed, that in the main process you pass a URL that usually is a file, say in the main page, let's call it the equivalent in WPF of the main view, right? Or the main window. So instead of that, what you can do is pass the full URL of your web page in the web, right? That is the first man approach. You can just do that on the shelf, and it will just take a few lines of code.
Yeah.
But it has certain problems. First, it can be subject to cross-scripting. Because when you do that, you are running not in a sandbox. Remember, that process is not in a sandbox. You have the IPC support. So you can actually connect to other processes in your application. So if somebody gets into your website and inject harmful JavaScript code, you're pretty much screwed.
Yeah. I will actually talk about this a little bit later on how to actually prevent
yes, how to protect and things like that. So it's very useful in certain occasions. For example, one of the things that we use it is that we have a mobile web server. We call it like that. And we want the people just to use the same direction. So we use Bonjour to detect which one is the server, and then serve the page from that URL. So because we have to do it in that way. But that is the first poor man approach. The second step is then moving that whatever you have in the web and doing it locally. And this is when things became fun, right? Because what you have to do is not just move the UI that is going to be in the browser process, but you have to move as well the backend. If your backend is in Node.js, it's the easiest thing ever, because you just basically have a Node.js application running locally. Let's say that you made your application in Express or in Koa. You just like run it locally, and your browser is talking locally through localhost. So it's pretty simple in that case. Just make sure that you are using as well HTTPS or some way of encryption between those two endpoints. The problem that you will face there is like database and things like that. I will talk later. Yep. And the third thing is that now that you did that, you can leverage the desktop. You can make your application look more like a desktop application. So see this as a many step. If you have to sell this to your boss, and this was the way that I sell it to him, by the way, as a CTO, I did that and said, like, in just 1 hour, okay, look, this is the application running in the desk. Because the first thing that I did was that. It's like, oh, yeah, and how it's working? Oh, just this. If you give me, like, another day, I will make it completely running locally. And I did the second step. And now that he was happy, he gave me like more time to make it look like a desktop application. But that's the way. You can see this as a step-by-step. If you have to migrate existing applications to the desk to bring the desktop experience.
Yeah. And if it's, sometimes you may have things like Web API and so on, and it just gets a little bit more complex. But this is where, when you're starting a brand new project, I think you've got a little bit more flexibility in your options, I suppose. So let's talk about that. The first thing, of course, is when you're creating a brand new application, you got to think of it more like a single-page application. Traditionally, when we used to write a lot of web applications, we have lots and lots of pages. We go click on a certain link and it takes you to another link, and then you hit the back button and you go back and things like that. Remember that a lot of these things don't exist anymore, right? Like there's no back button on the Electron shell anymore.
Exactly. You can provide your own back button, but why would you do that?
Yeah, that's right. So, and again, we've got this thing where remember design for the desktop is one of those things, right? We do a lot of design. We all think about responsive design. So it's got to work. We built an application, and it's all built in HTML and CSS. I want to run it on a mobile, and suddenly the responsive design, it just fits into a mobile device. But
you don't have to deal with that anymore.
Yeah. So remember, we are not building a mobile application over here. We are actually designing it to run on a desktop.
You can just go crazy with pixels if you want. You want 20 pixels, you got 20 pixels. It's like, because there's no other problem. You know the constraints that your application is going to run. Yeah. And because it's a window application, you say, like, you know what, this is the max size, this is the minimum size of the renderer, right? Yeah. So you are not constrained to those things. Yeah. The close button is a good example, Mahesh. Like, for example, when you are displaying, you have an inventory of, or a list of people. You want to see the details of one. And you just click in one person. And in a web application, what you have to do is just display in the same area, or use things like layovers or things like that to display the details. Yeah. And provide a close button. You don't have to do this anymore if you want to, because it's a desktop application. What you can do is just expand another browser window and not even provide a close button, because users already know how to close a window. They just click in the corner, right? Or in the corner. In Windows, it's on the other side, right? Yeah. So it's just look at a desktop application and don't try to emulate a desktop application anymore, like we do in web. Just use the desktop facilities.
Yeah. Remember that there are menu options at your disposal and things like that, and so you can activate the menu, do things with it. You can start thinking about, if you're putting it on the system tray, how are you going to use it? How are you going to be using the notifications? So you got to start thinking about like a desktop application and move away from a little bit of that web development mentality, I think.
Yeah.
That's because of the restrictions that it actually
now you don't need like the typical boot. All of you, how many of you have seen the Bootstrap templates? Everybody just use it, right? So now you don't need the typical Bootstrap template with main area and some areas.
So You typically have like a main
No.
first level of navigation, and then like a secondary navigation, and you'll have like a, I don't know, like a hero image or something like that, and followed by content. You don't have to stick to that. Interestingly enough, when you look at a lot of the applications that are being written in Electron, applications like Slack, they all follow a certain theme as well now. You have like your navigation on the left-hand side, and you have like a secondary navigation that pops up after that, and then you have a content panel and things like that. You don't have to stick to it. Obviously, if you look at the Nihilus application, it's very different. It's a mail client. But so Cristian, so what do we have to actually get people started with templates itself, right? There are a couple of templates that you can actually use.
Oh, yeah. If you really want to just start with something already made, I seriously recommend Photon. It's made by the guys from GitHub as well. One of the designers that create like already templates in CSS that are basically like the Mac desktop. That's the only problem, that because Mac is cool, he just wanted to be Mac guy, right? But if you want to create real cross-platform experiences, this another project named React Desktop that has no relationship with React. It's actually done in that way that the same controls has a Windows look and feel and a Mac look and feel. So in that way, you can reuse the same controls. And again, remember to design for the desktop.
Yeah.
Provide desktop experiences. Somebody asked you before, like somebody asked me, what about Electron for mobile devices? I don't think that, there are technical reasons because that will never happen, but Electron is designed for cover one problem, and it's desktop applications. So stop thinking about mobile and responsive design and things like that, and think about desktop.
Right. Let's talk about build pipeline, right?
Good. My favorite subject.
Yeah. I mean, like, first thing is that as soon as you get started, the first thing that you should work on is your build pipeline. If you don't, I mean, you should. So let's talk about build pipeline, Cristian.
Yeah.
Yeah.
We learned a lot around this build pipeline. The first thing that you need to understand, together when designing your application, is which platforms you are going to reach. And use your build agent in that platform. Yes, you can build Windows applications in Mac. Interesting, because you can now build Mac applications in Windows, right? So far, like, at least for Electron. But even when that happens, just use a build agent in a Mac for Mac applications and a Windows agent in Windows to build Windows application. Well, I mean agents because I don't know if you are using TFS or you're using TeamCity or whatever it is, but use the platform that you need because the binaries that you will need to provide, and we will talk later, the packaging format that you are going to distribute your application. We use cloud services in our case, so we use Travis CI for Mac, and we use Avior for Windows. Another characteristic, what I say there, is the packaging, as I said. You need to take care of the packaging because the Electron dot that you use there is okay, but you don't expect your users to do that. So Electron packages, what it does is that it prepares your application ready to ship and generate an MS-side package for Windows application, the first install, and a DMG package or a DMG file for Mac applications. And those, you can customize that. So you're seeing that in DMG files, when you double click, it has like a nice background, an icon, and messages, and things like that. You can customize that for your Mac application, the same for Windows. So Electron packages take care of that. For Electron packages, one of the interesting things that you have to take care is that if you remember the package.json, you always have a def dependencies and dependencies. So just be careful with that, because Electron packages is going to include just the dependencies. So be careful that the things that you need for development are just in def dependencies and so on. For example, Mocha for testing needs to be in def dependencies. So in that way, you don't distribute that together with your executable. Another thing that I learned this in the bad way, is that you go crazy with modules, right? You go like NPM and things like that. And we have two processes. We have the server process running in Koa, that was the API system that communicates with the database and things like that, and the UI that was written in React to communicate with data through REST protocols. The problem that we faced was that for local processing, we start using native modules to communicate to things like, for example, CouchDB and SQL Server at the beginning. And we start moving to Electron, we have certain problems. Because even when the main process, that is who span the Express application in that case, is based in Node, is not Node. When you try to build, it will tell you, I cannot recognize this version of Node because it's not called Node, it's called Electron. So when you use binary modules, AKA databases, embedded system, USB devices, for example, that are available in an NPM repository, what Electron Rebuild does is that it downloads the source code and rebuilds the source code so it's compatible with Electron. So you can use all those binary modules that you see in NPM, but to make it work with Electron, you have to rebuild them. But Electron Rebuild takes care of all the mess that involves doing that step. And another thing is that with Electron, you can reach as well mass applications. Mass applications are the Apple Store applications. So you can just make an Electron application that is available to distribute with Apple Store guidelines. There's just a checklist in the Electron website that is pretty clear what you have to do to reach that.
Yeah. And of course, being a developer, there are a couple of things that you'd be interested in. One is, what's the debugging experience, and how do you go about testing? So if I look at the debugging itself, I mean, pretty much when you start Electron from the command line, you can chuck in like a command line switch over there. You basically say --debug, and you specify the port number that it actually runs in. And you'd be able to connect it from Visual Studio Code and debug the application. In fact, if I jump into Visual Studio Code now, I can actually I can debug this application right out of Visual Studio Code. So notice this debug thing that they have over there, a debug icon, button, whatever you want to call it. Now you've got two options over here. One is the launch and attach. They're nothing more than configurations in the launch.json file. So I've actually gone ahead and changed the runtime executable to point to Electron rather than Node, because typically it actually launches a Node application. And once I actually set this up, change the details in my configurations, I can effectively go over to my debug and then launch my application right out of here. I'd also be able to set breakpoints in my code as well. So if I think I've already got a breakpoint. If I quit this application, let me do that. Notice that it's actually hit the breakpoint and it's stopped over here. So you can have a debug experience right out of Visual Studio Code if you wanted to. Now, there's one thing I want to point out. Now, you can actually debug the main process from Visual Studio Code. However, if you wanted to debug whatever is in your render process, then you have a problem. You can't do that. So for that, you can actually do it right out of Chromium. So let me show that as well. So if I did Control-Shift-I, and I can go over to my this, and let me open this other one.
Bless you.
Let's say I put in a breakpoint over here, and if I do a reload, notice that it's actually hit the debug. It's hit the breakpoint over here, and you can actually inspect your variables and do all kinds of stuff. So it's actually it works out pretty well.
Yeah, there's another tool named Electron that can do that as well, and you can see the IPC messages between things like, for example, like that. The IPC messages going from the main process to the browser if you want to debug that communication. So Electron is as well another tool. It's an open source tool that is available. Okay, testing. This is interesting as well, because testing, somebody asked yesterday to me, hey, do we have, well, it was not to me, I just like jumping. Yeah, I do that sometimes. Is there any web driver for Selenium to run in Electron? And the answer is kind of. right? Because you can just develop something like that. But remember that it's not just the renderer process. You have as well to see the integration with the desktop. So imagine that you have to test things like, for example, when I click edit copy, actually copy the information here in the clipboard. It's more than that. It's just the whole integration with the desktop. So there's that tool named Electron that is very much like Selenium, but for desktop applications using Electron. So you can test things in the same way that you just do with Selenium. Oh, you know what? If I click this, then this will change in the menu, and this notification will pop up, or the file dialog, the dialog for file open will appear. That tool can work in headless installations. That means not installations that don't have a head, it's that doesn't have a screen. Right? So just be careful with that, because for Linux applications, you have to install a specific X-free driver to just use the frame buffer system to test in headless application. That doesn't happen in Windows or Mac, but it's the only thing for if you want to reach the Linux desktop. My advice is don't try to reach all the 3 desktops at the same time. It's like a mobile application that just see what is your customer first. And Windows and Mac, it will be most common. And then if somebody asks, just go with Linux. But it's easy to test with the Spectrum in all these 3 platforms.
And I think security is probably
Oh yeah, security is, especially after like every time that Troy Hunt give a talk and things like that, and everybody gets scared.
Yeah, I think the first question is it safe to run? I mean, the first thing that we actually did was say, hey, you can actually throw in the URL of a location into your, when you create the browser window and then you run it. But we also say that it's okay when you're just doing a quick prototype and it's a first step in getting started. But think about it, right? So what if you go in and run untrusted remote content, and that starts injecting some node scripts, and you start deleting files from your file system and things like that, because you can actually do that now.
Yeah, and that could happen. Remember, you have access to everything. Yeah. So somebody actually could do a script saying delete start from C Windows. And the only thing that is going to stop you is permissions.
Yeah. So when you are running remote content, there's a way to prevent this. What you do is you run it within a web view tag, and that runs it within a sandbox environment. And then you also disable your node integration, because you don't want bad things happening in case someone is able to inject it. And here's the key thing, right? Even if you trust the content, let's say you're serving pages from your own website or whatever it is, you got to be serving it on HTTPS so that you know that there's no man-in-the-middle attack and is injecting some random stuff and things like that, right? So you got to make sure that you always run on HTTPS. Now, if you go over to the Electron documentation, they've got a checklist of all the things that you need to do. And it's a pretty good. I've got one good thing about Electron is that the documentation is actually pretty good. So there's a checklist of things. I would highly recommend actually visiting that and having a look at it.
Yeah. The other is, I put that in security, is everybody can see my code. When I say that you make your application native, it doesn't mean that magically it's compiling to binary code. You are distributing JavaScript files, right? And I see many people telling me, hey, how can I just obfuscate my JavaScript code? The first thing that I said, you don't need to obfuscate JavaScript. It's already obfuscated, right? That is a feature in JavaScript. But now, seriously, what happened with that code? Can I just somehow distribute something that is not JavaScript? Well, the first answer is using ASR files. ASR files are the equivalent to tarballs. Basically, it's a compressed format with all your JavaScript files. It's part of the command line. So instead of having the 10,000 files that it's 44,000 if you're using Angular 2 files and putting in the file system, you just compress everything in an ASR file that has everything inside. So it's a mini file system to say something like that. The problem with ASR files is that they are anti-tampering, so it's not easy. People can decompress that and just inject more things. So it's just a very small layer of support of protection. Now, if you really, really, really want to protect your IP and it's written in JavaScript, the next step you can probably try snapshots. Snapshots are like kind of difficult to use, and the idea is simple. You know that V8, the JavaScript engine from Chrome, what it does is that it takes the JavaScript code and it has a JIT system. It's just compiling time into native. So that compilation in time, when it does that, it generates native code and put that native code in an area of memory. So there is a tool named NWTS that you can just run it, and it takes that image, that binary image, and generate a binary file with that compilation. So basically, it's how your JavaScript code or the compiled JavaScript code will look in the memory of of V8 in that moment. So that is another of the options, using snapshots. The problem with the snapshots is that snapshots are read-only. And certain things like, for example, dynamic variables and things like that are not possible to represent because it would represent another snapshot in time. They tend to be really big as well. And my advice is, if you really want to protect your IP, there are two options here. One is use native code. So write it in .NET, write it in something like Go, so being cross-platform, so it will work. Good example is, let's say, see John there, LinkPad, want to use just the UI using Electron, but he already have the engine that does all the autocomplete and things like that in the backend. That process could be an exe file running in .NET or Core CLR or whatever if it's released one day. And then the UI is just Electron, and they communicate between them through IPC. The guys from JetBrains are doing something like that with Rider, but it's just having ReachApper running on a separate engine, and the UI is done in IntelliJ, and they communicate through a very lightweight protocol. And try to leverage the cloud. So you can just like put all that compilation and things like that in your cloud system and then just communicate. The only disadvantage there is that it's very difficult to make it offline. But just try to see how valuable is your IP. I say this because there was a case in Cambodia. Cambodia went through elections, and the system that they used was written in Electron. Because it was very delicate, it's an election data, to avoid tampering, what they end up doing was writing that process in Go to make it like real cross-platform. So think about leveraging things like that.
Just because we can actually finish up with some tips and tricks. Cristian?
Yeah. As I said, the first thing I trick is don't try to rewrite everything in JavaScript. If you already have something, try just to pack that together with your application. In our case, for example, we use many things. We try to replicate, replicate the infrastructure that we have in the cloud in a small set of process running locally. So in the cloud, we have a queue. We use like the queue system from the cloud. So instead of that, we use like a small queue system running in the machine, right? Not just MSQ or things like that, just a small queue process. The same with database and things like that. So just leverage all those parts and don't try to ship everything together in the same executable. As is possible, just have small pieces that are distributed together. Don't try to embed everything in JavaScript. If you have to do a lot of calculation and a lot of work, use web workers. And what I mean is, again, you have Chromium. So what you can do is just create web workers to do that communication. They communicate through IPC as well. And let them do like the communication in the background. Remember that you are running in Node and in JavaScript in the render process. And that means that it's just single-threaded. And include the DB with the app. This is my favorite part, because we are used to, when it's in the cloud, we use SQL Server, for example, Azure, and that has all the database. But if we want our application to be completely offline, that was our case, we have to create a way to have like a local database that was well synchronized with the main database. The local database part was easy. We use SQLite for we have two types of database. One is NoSQL database, and then the other is the relational database. So our database engine is independent of the database, or our database ORM is independent of the database. So we have SQLite running for the local instance with their own schema and things like that, and it runs in SQL Azure for the cloud. And for the NoSQL database, we use Mongo in the cloud, and we use another one that is LumenDB, that is an embedded database as well for NoSQL that is compatible with the protocol. So you just try to embed that in again, as a small versions of those things running locally. And auto-update is possible. I didn't show that, but if you just having, if you just show Atom, you will see a small squirrel in the corner. And sometimes it's blue. That means that it's an update. One of the things that the guys from GitHub developed together with Atom was a squirrel. That is a cross-platform updating system. That what happened is that you just use NuGet as a delivering mechanism, or every time that you have an update, you just put the new package, and it will auto-update the application. So you can embed auto-update in your application for free without adding anything. So that is one of the problems that is already solved, and they already have that. And it's cross-platform.
Yeah. I mean, this is critical, right? Because when you're deploying a web application, it's very easy. You go deploy it on the server one time, and then everybody gets it at the same time. But when you've got a desktop application, people have the code running on their machine. So you need to be able to provide updates periodically as well. And you can't expect for them to actually go and do it themselves. So with Squirrel, you can actually do a lot of auto-update. You can do the auto-update. You can trigger that off. So that's all we actually had. I mean, our aim was basically to give you a bit of an introduction to Electron and show you what kind of applications are being written, and just enough to get you interested and get started programming in.
Yeah, just
in
go
Electron.
and try it. Again, like this solved the problem when your boss, as I said before, say like, Christian, we have to migrate this to the desktop, and just try it. Just use the 3-step and do it, and it worked. He's here.
So thanks for coming. Those are Twitter handles over there. If you've got any questions, you can actually send us. Or we've still got a couple of more minutes, I assume, if you've got any questions.
What's the name of that local NoSQL?
I think it was like LumenDB. They just recently, I can't remember because.
What the question was, what's the name of the local NoSQL database?
I will tell you in a second.
Yeah.
It's in my list of forks.
Any other questions? Yes.
View on using Spark frameworks like React or Angular in Electron?
Okay, so the question was, what's your opinion on using SPA frameworks like React and Angular? We've decided to go React. I mean, we went through an exercise of trying to figure out which one is better, and
NeDB. NeDB. NeDB.
Yeah. So we ended up choosing React. I mean, I'm not here to kind of like debate whether Angular is better or React is better.
I'm not really talking about much of the same,
Yeah.
using a Spark framework.
Absolutely, yep.
We're actually going just
Yep.
with raw JavaScript.
Yep. Yep. So to answer your question, we use React. So the answer is yes. Yeah.
And you didn't find performance issues with that one?
No, it was quite good actually. Yeah.
Yeah, it was actually because what we did is we just replaced the communication to have in the same process and then use IPC in the local version. So we didn't have like any issue. The only issue that we are, not issue, but the step that we are right now is making it look more desktop-like. And actually React has helped us a lot with that because we just replaced the components for doing that. The only thing is that now we have two, not forks, but we have two versions of the source code. And we are still learning because the same as React, It's a new thing, learning how to make really big applications. And now we are tackling 2 types of applications, an SPA for the web and a desktop application. So that's the only problem. You end up with having 2 different versions of the source code.
Yep. One last question, sorry.
How much interaction with the desktop do you actually get? Can you talk to like Windows services or?
Yeah, you can. You can. There are actually modules. If you want to do that, we actually studying that because we have a problem to solve in that way. You can create a module, an NPM module that is a Windows service. Then with the desktop, there's the other part. Depends on what you have to do. I'm crazy as hell, so I wanted to do my own components to just extend, for example, the internet, the Explorer browser. I'm almost there. I already been able to do that in Mac, not using COM, but using like the native stuff. So you can just do certain things in the Finder window that are like just native, but it's possible.
Yeah.
So you will have to deal with, if you want to do that integration and like go a step further, expect to just get your hands dirty.
Yeah. We've run out of time, guys, but we'll take questions like.
Yeah, I will be around. So
sure.
just.
All right.
If
thanks
it's
for
not
listening,
me,
guys.
it's not me. Yeah.
And make sure you put the green notes on the way out. No, just be honest, right?